This is an attempt to explain strategy design pattern in as simple way as possible. So let's consider we're working in a gaming company and we have a player character who can right now punch. So the player character can right now punch and eventually the game is going well and uh, for new improvements we'll have new requirements. And the new requirement is that the player might get a gun. So if he gets a gun, then uh, there's an so he can attack with the gun. So player has a gun and player can shoot. So how does the attack work? Attack is gun dot shoot. So we have a player who has a gun and he'll use that gun to shoot. Then let's say we have another requirement eventually when the game goes well, you might as well get new weapons. Let's say you have gun and bow and arrow as two different types of weapons. At a time, the player can have either gun or bow and arrow, or at least when you consider any game, you can use one weapon at a time. You can hold two, but you can attack with only one in most of the games that I've seen so far. So let's consider you have both of them. If you if you have, let's say, one class for gun and one class for bow and arrow, and you utilize that in this way that I've shown here, what happens is eventually down the road when you get like uh, a dozen more weapons, it gets very difficult to maintain. So instead, what we can do is we can simply have an interface, and this interface can be called as weapon, and it will have a method called attack, and we'll implement it as either gun. I mean, there are two implementations, which is one of which is gun, and the other one is bow and arrow. Both of them will have gun. Both of them will have attack method, and we can make use of that attack method. We also have set weapon in the player here. So we we can have this to set the weapon. So let's say the player has touched a weapon, or let's say he has touched it and then clicked on A button in the joystick, and then you pick that weapon and that will be set as your default weapon. Or let's say you have a button to, let's say, switch weapons, then you can use that to set the weapon so that uh, whenever you attack here, it will internally use the weapon dot attack. Now let me read out the strategy pattern definition and explain it to you in this example. So, strategy pattern defines a family of algorithms, encapsulates each one, makes them interchangeable. Strategy lets the algorithm vary independently from clients that use it. So, in this case, the family of algorithms we have are gun and bow and arrow. These are the two uh, family of algorithms we have. We can, let's say, have more uh, family of algorithms, which can be like, let's say, sword or any other weapon. Okay, encapsulating. So encapsulates each one. So each weapon is encapsulated in its own class. So we have one class for gun, we have one class for bow and arrow. We'll probably have one more class for sword or knife or axe or whatever. And each weapon is encapsulated in its own class, implementing the weapon interface. So each of them will implement the weapon interface, but it will have its own class. So it will have a specific uh, definition or specific implementation of the attack method that is specific to gun or bow and arrow or whatever the weapon is. So that's encapsulating each one and makes them interchangeable. So at the runtime, or you can like call the set weapon method, and you can change the weapon. So you can call the set method weapon, and you can change the weapon. So now when you call the attack will be performed based on the weapon that the user possesses, right? So this is interchangeability. And strategy lets the algorithm vary independently from clients that use it. So now let's say you have two different strategies or two different classes here that implements the weapon interface. Let's say you have third one. You don't have to change anything in the player method. You can directly add a third one here, and when you call the set weapon with the new, let's say, uh, sword class here, and it also implements this particular interface. Now, when you set the weapon as sword, it will automatically uh, attack with the sword, right? So strategy lets the algorithm vary independently from the clients that use it. Here, the client that uses the strategy is player, right? The strategy that we have here is weapon strategy. And we can have a gun strategy, bow and arrow strategy, or a sword strategy. But whatever the strategy is, you can change it without making any changes independently from the clients that use it. So let's say a player is using a weapon right now. Let's say a, uh, opponent or enemy is also using weapon right now, and you can make changes in the strategies that in the weapon strategy right now or weapon interface, what the number of weapons you have right now, and it doesn't affect either the player or the enemy. Enemy can also have a weapon, and it doesn't really matter how many weapons you add there, right? That is a strategy design pattern.